Welcome everyone to our new lecture. Let's begin the lecture. So we'll start from the properties of the normal distribution curve. So the normal distribution curve mu refers to the mean and sigma refers to the standard deviation. Okay. So the difference of mu minus sigma to mu plus sigma contains 68% of the measurements in our normal distribution curve, while mu minus 2 sigma to mu plus 2 sigma contain 95% of it, and mu minus 3 sigma to mu plus 3 sigma contains 99.7% of the data. Talk about graphic displays of basic statistical descriptions. So first is the blocks plot, which is basically a 5-number summary. Then we'll talk about histogram, where x-axis are values and y-axis represent frequencies. Then we'll talk about quantile plot, in which each value is paired with fi indicating approximately 200 fi% of data which are less than xi. Then we'll talk about quantile plot, where graphs the quantile of one univariate distribution against the corresponding quantities of another. And then scatter plot, where each pair of values is a pair of coordinates and plotted as points in the plane. We'll talk about each and every plot in the coming slides. So box plot, we talked about it. It is a 5-number summary of a distribution, and the 5 number are minimum, q1 that is quartile 1, then median or quartile 2, q3 quartile 3, and maximum value. So here we need to arrange the data in the ascending order. And box plot, data is represented in the box. The ends of the box are the first and the third quartiles, which is basically known as the height of the box, or IQR. IQR means interquartile range, which is difference of Q3 minus Q1. The median is marked by a line within the box, and median is our Q2. So two lines outside the box extended to minimum and maximum. Fine. And outliers are points that are specified beyond outlier threshold and are plotted individually. So for identifying the outlier, so Q1 minus 1.5 into IQR, or Q3 plus 1.5 into IQR is the threshold, and beyond that the points will be marked as outliers. If you want to look at visualization of how a 3D box plot looks like, here is a visualization. So histogram analysis. Histogram are basically graphs displaying tabulated frequency with bars. It shows what portion of cases falls within a category. It is different from a bar chart, and the area of the bar that denotes the value, not the height in a bar chart. The categories are usually specified as non-overlapping intervals of some variable. The categories must be adjacent in a histogram. So what actually our x-axis are? X-axis are basically categories. Histogram often tell more than box plot. Okay, the reason behind that is the two histograms shown in the left may have the same box plot representation, the same values for minimum, Q1, Q2, Q3 max, but they have rather different data distribution. So what actually the thing is, with the box plot we can gather limited information and basically only 5-number summary, which is not in the case of a histogram. Quantile plot, we talked about it. So all the data are mapped, and each point represent how many, like if we talk about the value 0.250 on x-axis, so the corresponding value on the y-axis, which is marked as a diamond structure, represent how many values are, or how many percentage of values are less than that. So box plot, quantile plot begins with mapping at 0 and maps up to 1, which is 100% of the data. Now we'll talk about quantile plot. So graph the quantile of one univariate distribution against the corresponding quantiles of another. So view, is there is a shift in going from one distribution to another? So the question is, let's see the example which show unit price of items sold at branch 1 versus branch 2 for each quantile. Unit prices of items sold at branch 1 tend to be lower than those of branch 2, and the reason behind that is you have to identify from looking at the figure. Just pause the video and look at it, so you might be able to identify what's the reason behind. Because if majority of data would have been lying below the line, which is drawn as a straight line, then that has been an opposite case. Fine, just look at it. Then we'll talk about scatter plot. Provides a first look at bivariate data to see clusters of points, outliers, etc. Each pair of values is treated as a pair of coordinates and plotted as points in the plane. So basically these are mapped as points, and what advantages of the scatter plot is we'll be discussing. So look at these scatter plot. What inference can you gather from these? So we'll talk about the first scatter plot on the left hand top one. So what actually inference is, if the value of a quantity grows, then the other quantity also increases. Like if we are increasing the value of one item on a or a one variable, then the corresponding y variable will also increase. The example can be age and height. So with the age, the height is also increasing, and on the right hand side top figure, you can see if the value of 1 is increasing, then the corresponding value of other is decreasing. Okay, so example can be crude and gold. So if the prices of crude goes up, the prices of gold falls down, so they are negatively correlated. And if you see the bottom figure, you won't find any relation between the two figures. So if the value of one affects the value of other, and if they directly affect, like one is increasing and other is increasing, then it is positive correlation. If value of one is increasing while the value of other goes down, then it is negatively correlated. And if there is no relation between the values, then it is unrelated. So take another examples of uncorrelated data. So this figure, you don't identify any relation between the figures. So what you can say is that these figures are representing uncorrelated data. So for any queries related to our this lecture or regarding our previous lecture, kindly mail me at utsav@gwca.ac.in. I'll be looking forward for your query, and any suggestion you want, you can just mail it. Thank you. Hope you are doing well. Stay home, stay safe,